You know, we all have this picture in our heads of the Big Bang, right? This single fiery point that just explodes into everything. A violent, chaotic beginning. But what if that picture is wrong? What if the Big Bang wasn't an explosion at all?
What if, instead of a sudden blast, the universe unfolded? Kind of like a sound, a single perfect musical chord that resolves itself into reality. It's a pretty wild idea, and it's the core question behind a model called the Harmonic Scale Framework, or HSF. And it asks us to rethink everything we know about the very first moments of existence.
So in this view, the Big Bang wasn't a one-and-done event. It was a harmonic cascade. Imagine a series of unimaginably high-frequency waves collapsing, one after the other, each step down creating a new layer of our reality. It's a universe born from harmony, not from chaos. To really get our heads around this cascade, we have to go back, way back, before the beginning as we know it. The HSF model talks about a state it calls the pre-resonance era, a time, or a non-time really, that existed before space and time even meant anything.
So what on earth is pre-resonance? Well, think of it as a state of pure, perfect oscillation. It's like the potential for a sound, but without any air for the sound to travel through. There's no space, no time, no particles, just a pure, disembodied frequency.
We're used to thinking about waves as ripples moving in something, right? Like waves in an ocean. The ocean has to be there first. The HSF model flips that completely on its head. It says the universe began as a pure tone without a medium, and the unfolding of that tone is what actually created space itself.
And just think about what that means. No space means no here or there. No time means no before or after. No particles means literally nothing to touch. It's the most fundamental state you can possibly imagine, just this pure, coherent hum, waiting for a trigger to unfold into, well, everything.
So what was that trigger? How do we get from this state of pure frequency to the universe we see today? Well, the answer in the HSF model is something it calls the Great Harmonic Cascade.
So the story goes that our universe began with a moment of instability. Those highest, purest frequencies just couldn't maintain their perfect harmony. They broke, they snapped, and they fell into a lower, more stable harmonic level. It wasn't an explosion. It was more like a guitar string snapping and settling into a lower, deeper note.
And this cascade happened in distinct steps, or harmonic tiers, that the model calls K levels. Let's just walk through it. The first collapse, into a state called K6, created geometry itself. Bam! Space and time are born. The next fall, into K5, formed the very fabric of space-time. Then K4 laid down the blueprint for all future structures, like galaxies. It's only after all that fundamental groundwork is in place that we get to what we usually think of as the hot Big Bang, the universe filling with plasma in tiers K3 and K2. And finally, in K1, matter as we know it locks into place. We can even map this whole cascade onto a more familiar timeline. Geometry is born in just a tiny, tiny fraction of a second. The seeds for entire galaxies are laid down before the universe is even a millionth of a second old. The hot, soupy plasma that we always associate with the Big Bang only really gets going after that. And from there, things proceed pretty much as we know them. Atoms form, light breaks free, and eventually the very first stars begin to shine.
Now, this harmonic way of looking at the universe, it leads to some truly surprising, even shocking implications. Not just for the beginning of time, but for the very nature of energy, of matter, and even the ultimate fate of the entire cosmos.
So here's a simple question with a mind-bending answer. If all the matter and energy we see around us is just a lower frequency version of that original harmonic energy, where is most of it stored today? You'd think it's in the particles that make up you, me, and the stars, right?
Well, the answer is a pretty emphatic no. According to the HSF model, if you take a single proton, almost all of its mass, we're talking over 99% of it, doesn't come from the matter itself. It's actually energy that's stored in that underlying K4 field, that cosmic blueprint we just talked about. The actual stuff, the quarks and fields we think of as the proton, that's just the final 1%. Mass, in this view, is basically just stored potential energy.
And if that's true, it changes everything, especially how we think about the end of the universe. I mean, if energy isn't just locked away in matter forever, what is its ultimate fate? Does it all just fade away?
The HSF model predicts a really quiet, gradual end. Star formation will eventually stop, black holes will cool down and just become these static anchors in space. And then, over truly unimaginable timescales, the leftover energy of the universe won't just disappear. It'll actually reascend the ladder, returning to that higher-level K6 geometric state that it came from in the first place, a kind of cosmic freeze-out.
Okay, I know what you might be thinking. This all sounds really cool, almost poetic, but is it, science? And the answer is a definite yes, because the harmonic scale framework makes specific, testable predictions about what our telescope should be able to see.
And here are just a few of them. The model predicts that when we look at how gravity bends light, something called gravitational lensing, it might actually be tracing these smooth energy fields, not just the lumpy matter we can see. It also suggests we should find some surprisingly massive galaxies really early on in cosmic history, which, by the way, is something astronomers are starting to see with new telescopes. It even hints that the strength of gravity itself might be changing, just ever so slightly, over billions of years.
So you see, these aren't just philosophical ideas. Each one of these predictions gives astronomers a real, concrete signal to go look for. And whether they find these signals or not is what will ultimately decide if this harmonic view of the universe holds up and moves it from a beautiful thought experiment into the world of real, observational science.
And all of this leaves us with one last, really provocative thought. For hundreds of years, we've thought about the universe as being built from the bottom up, starting with tiny little particles that clump together. The HSF model asks us to consider the complete opposite. What if the universe was built from the top down? From a state of pure, perfect harmony, which then cascaded down into the beautiful, messy complexity we see all around us today. Is reality just a collection of things, or is it the echo of a cosmic note?